Okay guys, this is Algebra 2 Lesson 6. What we're going to be working on now is multiplying and dividing fractions. Fractions that may have monomial, binomial, and polynomial numerators and denominators. Okay, this is the rules that you should follow to solve or to reduce and simplify these fractions. First of all, you factor everything that's possible. Here there's nothing to factor, so we don't have to worry about that. Divide out the common factors, and then we can, after everything's been simplified as much as possible, then you can multiply everything. And then if you need to, you can simplify further. So just to give you an example, let's do number 1. Nothing to factor here, but I'm going to write this larger so you can see it better. It's 5c to the third over t to the fourth times t cubed over 6c squared. So one thing we recognize, well, we can simplify t to the third and t to the fourth. That divides out. 3 t's will cancel out here, t to the third. There'll be a t left over here. So I'll show you what that looks like. T to the third looks like this. T to the fourth looks like this. Each t divides out to 1. So that will divide out to 1. That will divide out to 1. And there's 1 t remaining in the bottom. That's this t right here. Similarly, we have a c cubed here and a c squared here. That will divide out. There'll be a c left in the numerator. Let's find out what this is going to become. 5 times c times this is 1 is 5c. T times 6, this is 1, is going to be 6t. And this is the fraction that was multiplied and reduced as much as possible. Okay, so that was question number 1 over here. Number 2 is similar. You might want to try this one on your own. So let's take a look. We have 12x over 5y times 15y squared over 36x squared. Now you could multiply and then reduce, or you can reduce and then multiply. And I'll show you what I'm going to do. I'm going to reduce and then multiply. Use a red pen here to make this a little clearer. So one x will cross out, leaving an x here. One of these x's canceled out. There's an x left. There's just a 1 here. With the y's will cancel out. There'll be a y left in the numerator. And then this 12/36, that can reduce to 1/3. And 5 into 15 becomes 3 over 1. What you have left over on top is 1 times 1 times 3 times y. That gives us 3y in the numerator. And 1 times 3 times x is 3x in the denominator. And as you can see, you can reduce even further. These 3's divide out to 1. So you just get y over x. Okay? The next problem is actually a division problem. I don't know how well you can see that. I'm going to rewrite that problem for you right here. This is problem number 3. We have 7x over x squared minus 49 divided by 49 over x minus 7. Now, you probably remember that when you divide fractions, you can change that into a multiplication problem by doing keep the first fraction, leave it alone, change the operation to multiplication, and then flip the second fraction, do the reciprocal of that fraction, and you get x minus 7 over 49. Now you're going to factor what you can. This is the only thing that can be factored. It's a difference of 2 perfect squares, so that's x plus 7 and x minus 7. And now we can simplify more. This x minus 7 and this x minus 7 divide to a 1. This 7 and 49 simplify to 1/7. What you have now is 1, and there's an x here, so 1 times x times 1 is 1x. And the denominator, we have x plus 7 times 1 times 7, so that's 7 times x plus 7, and that's how we do division, and that's how we do a problem that has binomials or things that need to be factored. We'll take a look at another example right here. I get another sheet of paper, only because this is pretty small and I want you to be able to see it better. So let's take a look. What do we have? We have 4x squared over x squared minus 81 times 81 minus x squared over 8x. Factor what you can. Factor if possible. This can't be factored. I'm going to rewrite it leave it alone. That's x plus 9 and x minus 9. This can be factored. Be careful how you factor this. The number is first, so that's going to be 9 plus x and 9 minus x. This can't be factored. Well, let me go over something with you. X plus 9 and 9 plus x, those are exactly the same. There's no difference with these two whatsoever. Addition is commutative, so you can write x plus 9 as 9 plus x, backwards or forward. So that's going to divide out to 1. But this is different. X minus 9 and 9 minus x are not identical. As we saw in the last lesson, they're actually the exact opposite of each other. If one is equal to 9, the other one's equal to negative 9. If one is equal to 15, the other one's equal to negative 15. But it really depends on what the value of x is. If a specific value for x, I'll give you an example. If x is 1, this will be negative 8, but this is going to be positive 8. So when we want to simplify this, they will divide out, but they won't divide out to 1. They'll divide out to negative 1. So I'm going to put the negative 1 there for that cancellation. All right? Then we have this other stuff that we can simplify. 4 goes into 8 2 times. And this x squared, x goes into x squared x times. And let's see what we have left over. What we have left over is a negative 1 on top times this x. So negative 1x. And in the denominator, we just have a 2. So this whole multiplication problem simplified to negative x over 2. Okay? All right, so let's go take a look at the next page. We got more similar types of problems. We'll go through them so you can get the hang of them. Maybe you could try the next problem on your own to see if you can do it. I'm going to write it a little bit larger. You got 3s over s squared minus 9 divided by 9 over 3 minus s. Remember, division, you can change this whole problem into multiplication by leaving the first fraction alone. You won't change it at all, leave it as it is. Change the division into multiplication, and then do the reciprocal or flip of the second fraction. And now we can simplify. Well, again, before we simplify, we're going to try to factor. This can be factored. That's going to be s plus 3 times s minus 3. And as we said before, s minus 3 and 3 minus s are opposites of each other. They're actually literally negative 1 of each other. So when we divide them out, it will leave a negative 1 times a negative 1 there. 3 goes into 9 3 times. So what we have left is negative 1 times s. So it's a negative s on top over 3 and s plus 3 on the bottom. 3 times s plus 3. Nothing else can be simplified. That's what you get for problem number 5. Let's take a look at problem number 6. It looks more complicated, but it's really not that difficult. This is a multiplication problem. Let me write it out so you can see it a little better. X squared plus 5x plus 6 over 2x minus 4 times x minus 2 over x plus 3. This could be factored. X plus 2 times x plus 3. This can be factored by pulling out a GCF of 2. That's going to be 2 times x minus 2. And we get an x minus 2 here and an x plus 3 here. And now these divide out to be 1s. These divide out to be 1s. Nothing else can be simplified. All we have left is this x plus 2 over 2. Don't simplify. This 2 is binomial with this x. You can't divide this 2 into that 2 unless you also divide this 2 into the x. You don't want to do that, so just leave it like this. All right, let's take a look at the next problem. Now we have another division problem. You know what to do first. I'm not going to rewrite the problem. I'm just going to rewrite it as a multiplication problem. The first fraction was 9x minus x cubed over 9 plus 3x. Change the division to multiplication and take the second fraction and write the reciprocal of it. Then factor everything. This can be factored by pulling out an x. So we're going to get x and then 9 minus x squared. Actually, that can be factored further. That's going to be x, 3 plus x, and 3 minus x. This we can pull out a 3. So this is gone. We can pull out a 3 and we get 3 plus x here times 20. And here we could pull out a 15 and we get x minus 3. So let's see what we got here. Well, 3 plus x and 3 plus x, those divide out to 1. Now here, the 3 minus x and the x plus 3, those don't exactly cancel out. They divide out to a -1. And the 15 goes into the 20. Well, actually 15 doesn't go into 20, but 5 goes into 15 3 times, and 5 goes into 24 times. So you can simplify that. And let's see what we have left. We have a -1 times x times 4, so that's a -4x in the numerator. And we have a 3 times a 3 is 9 in the denominator. And it looks like that's all we have left. So we got -4x over 9. Okay, that was question number 7. Okay, we're up to question number 8. This is another division problem. I'm not going to rewrite the problem. What I'm going to do instead is I'm going to write it out this way. By the way, c minus d squared is the same as c minus d times c minus d over a squared. Change the division to multiplication and do the reciprocal of this fraction. It's going to be c squared minus d squared. Now we can factor this. This is going to be c plus d, c minus d. It's a difference of two perfect squares. And let's see what we can simplify. Well, first of all, the c minus d's cancel out, at least one of them. A squared goes into a cubed a times, so there's an a left there, there's only a 1 down here. Nothing else can be simplified, so what do we have? We have an a on top times c minus d over, all that's left on the bottom is a c plus d. These are not like each other, so you can't simplify that. All right, so this was question number 8. Let's take a look at question number 9. Question number 9 is a multiplication problem. I'll rewrite it for you. Y squared minus 16 over 3y cubed times 15y over 2y plus 8. Now I'm going to factor what I can. That you could factor, it's easy. Y plus 4, y minus 4 over 3y cubed times 15y over, here we could pull out a 2 GCF, y plus 4. So y plus 4 is divided out to 1. 3 goes into 15 5 times. Y goes into y cubed y squared times, only 1 left over there. And let's see what we have left. We have a 5 on top, times y minus 4 over 2y squared. And that's how that becomes simplified. And we have one last problem to do. Yep, just one more. Problem number 10, it's a division problem. You should know what to do there already. With a division problem, I'm going to rewrite the first fraction as is, no changes, but then we're going to change the division to multiplication, and we're going to do the reciprocal of that second fraction. Now we're going to factor everything we can. This can be factored at c minus 6 and c plus 4. This we can pull out as c times c plus 4. This cannot be reduced. And this is a difference of 2 squares, c plus 6 and c minus 6. And let's see what we got here. C plus 4 is they divide out to 1. C plus 6 is divide out to 1. C minus 6 is divide out to 1. And you have c left. Now here's the thing. I didn't put 1s in the place of my cancellations, but I should have, because you think you're going to get the answer being c. But that's not true. There are 1s up here. So the numerator is 1 times 1 times 1 is 1. The denominator is c times 1 times 1 times 1 is c. It's not c, but 1 over c. The numerator has a 1 in it, okay? So that's how you do multiplication and division of complex fractions like this. You should be able to do the homework with this information.